24, it says identify the x-intercepts, y-intercepts, local maximum, and local minimum of the graph of. The function is 1/2 x plus 3 times x minus 2 squared times x minus 1. Then describe the end behavior of the graph. So it's asking you to do all these things here. So whenever we're asked a graph, we're going to plug it into our calculator first. So we're going to do 1/2 in parentheses, and x plus 3 in parentheses, x minus 2 in parentheses, and you square it, and x minus 4. Alright, when I look at this, I have 1, 2, 3, 4 x's. Okay? And it looks like a touchdown as well. So I know it's a degree of 4, so it's going to be even function, it's going to look like a touchdown. And that 1/2 is a positive, so it's going to be a positive touchdown. So it goes through -3, goes through +2, and it bounces off of +2, and then it goes through +4. Remember x-intercepts, there's tons of different ways you can do it. Since it's in factored form, you set each of these factors equal to 0. So x equals -3, x minus 2 equals 0, so x equals +2. And the thing with +2 is if you look at your graph, it bounces. So that's an even multiplicity. It has a multiplicity of 2. Okay, so I'm going to put multiplicity of 2. And I also have, if I set x minus 4 equals 0, I get 4. You can clearly see those three numbers on your calculator, on your graph. The other way is you can go to your table, and I should have y equals 0 for each of those three values. So -3, I have a 0 next to it. +2, I have a 0 next to that as well. If I look at +4, I have a 0 next to that as well. Alright, so what I can do now is actually go ahead and plot these three x-intercepts. Okay. Your y-intercept. You could do it algebraically by just plugging in a 0 for x, or you can go to your table and look at, okay, 0, -24. Alright, so it's off of my graph, so I'm going to put like a little reminder to myself that it's off of my graph. I'm going to put it down here. Local maximum. So let's go to our graph. Remember, it's the top of a hill. So I definitely see a top of a hill right here, right at that multiplicity. And I think it's 2, 0, but I just wanted to be totally sure. So I hit second, trace, maximum is option 4. It's asking you to the left. Go ahead and go to the left of that hill. That's good. I'm going to hit enter. Now it's asking you to go to the right of the hill. That's good. I'm going to hit enter one more time when it says guess. My maximum 1.999986. Remember, whenever we see this E, that's just scientific notation. So you got to think, I got to move my decimal point over to the left 11 times. That's really close to 0. Okay, so we're going to round to 2 decimal places. So my maximum is actually going to occur at 2, 0. All right, local minimum. Remember, local minimums are bottoms of a valley. Okay, so there's one definitely right here, and there's one all the way down here. What we can do is actually zoom out. So hit zoom 3. Okay, and we move this cursor right in the middle so I can see the whole graph. Make sure that I definitely have a minimum down there. So, okay, so it definitely goes down and then back up. So there's a minimum down here. So hit second, trace, option 3. I'm going to focus on the one that's over here. So I have to go to the left. I know this is definitely to the left of it. I hit the right arrow button. I definitely know this is to the right. Hit enter one more time when you see guess. One of the minimums is going to occur at -1.63, -50.82. So that's one of them. That's an ordered pair. We're going to do the same thing with this minimum right here on the right side. So I'm going to hit second, trace, option 3 again. Go to the left. And then go to the right. Keep even all the way over here to the right. Hit enter one more time. 3.38. Okay, so it's going to be 3.38 and then 3.77. Okay, so we have a few things that we can plot. There's my maximum. Negative 1.63, negative 50 is all the way down here. 3.38 and then 3.77. I'm sorry, is that negative or positive? Negative 3.3. So that's a huge difference. Negative 3.37. Okay. Don't mind that extra errant dot. And we're going to go to our table and plot a few more points, if we can. So negative 4 is positive 144. So I'm going to put a reminder that it's off of my graph. Negative 2 is all the way down here. Okay. Let's see. At 1, it's negative 6. Okay, then it goes back up. Bounces off here at my local maximum, comes back down, and then it goes back up. So another one that we could do is 3, negative 3. And then 5, 36 is off my graph. So it goes from up here, goes down, comes down to my bottom, goes through my y-intercept, comes up, bounces off of that 2, bounces down to my minimum, and goes up. Okay. Put arrows at the end of your graph, and there's my graph for that one. So, as x approaches positive infinity, that means what are my as x is on the positive side, so on the right side of the graph, well, my graph is going up to positive infinity. As x is approaching negative infinity, you're looking at the negative x values. Well, on the left side, my graph is also going to positive infinity. Okay, it's really important that you guys are able to go ahead and get your local maximums and also your local minimums by using those functions on your calculator. So make sure you guys are able to do that, and make sure you guys understand how to get your y-intercept as well.